Don't forget that that little division bar means division. The first one is 3m plus 9 divided by m plus 3. Now, this is a single entity, as is that. So in order to do this properly, the first thing you need to do is factor as best you can. 3m and 9 share a factor of 3, so it's 3 times m plus 3. I'm going to stop right there. Here, here. Is there any questions why I factored out the 3 and why it's m plus 3 in parentheses? Okay. The bottom entity shares nothing other than a 1. M plus 3 it is. Okay? Because the numerator and denominator share a factor of m plus 3, when you divide a number by itself, it becomes a 1. So in effect, those items cancel out, giving you an answer of 3. Okay? You don't realize that you're already doing this when you do something like this. Now, I'm just going to leave it real simple. You're going to say, well, duh, Mrs. Myers, it's 3. Yes, it is. But if I factored the top so that it shared 4 as the factor, I am reducing it by a factor of 4. Okay? This is just a more complex version of something this simple. All right? Moving on to number 2. Any questions on number 1? Moving on to number 2, where it's the exact same idea, 2n plus 8 over 3n plus 12. What can I factor out of 2n and positive 8? Greatest common factor. Anybody know? 2 is right. Does that give me n plus 4 there? Missing a 1 there. What can I pull out here? 3, which leaves me what? N plus 4. Okay? To check it, 3 times n is 3n. 3 times 4 is positive 12. So the n plus 4s reduce each other. N plus 4 divided by n plus 4 is 1, leaving me with 2/3. Okay? Number 3, factoring gets a little more complicated. A squared minus 16 over a minus 4. The numerator, this is the difference of what? Squares. So the square root plus the square root multiplied by the square root minus the square root. Okay? That's the pattern. When you recognize you have two perfect squares separated by a difference, it's the square root plus the square root here, square root minus the square root there. All of that over a minus 4. I'm just going to put it in parentheses for fun. I don't know why, I just do it. The a minus 4's reduce, leaving us with an answer of a plus 4 over 1. Number 4 looks like it's another difference of squares. B squared minus 9 over b plus 3. B plus 3, b minus 3, b plus 3. Anybody confused as to why I'm factoring this way? I don't want to rush through this, but I also don't want to waste your time either. The b plus 3's cancel. B minus 3. Why did the b plus 3's cancel anyway? Go. Divide it by itself, you get a 1. Bravo. All right. For sake of time, oh shoot, I forgot to give you restrictions on the variable. Dadgummit. Okay. Restrictions on the variable. What that means is...
We have Ashley Harwood and Jasmine Stewart to business class, please. Ashley and Jazz to business. Thank you.
The denominator cannot equal 0. So in its original form, if m is equal to -3, then we have a 0. So m cannot equal negative 3. Otherwise, that creates a 0 denominator, and we can't have that. Here, what will create a 0? Negative 4. Negative 4 cannot equal a negative 4. Okay? Very good. And you just go back to the original thing. Right off the bat, you can restrict your variable. Right here. What can the variable not be? 4. A cannot be a 4 because 4 minus 4 is 0, and that makes the problem nonsense. What can the variable not be? Negative 3. Because if you plug in a negative 3 and a positive 3 is a 0, and you can't have that, okay? So this is your answer, this is your restriction. When it says simplify and state the restrictions, okay? You have to state the restrictions. All right, number 5. X squared minus 2x plus 1 over x minus 1. Anybody see what that top thing is as far as a pattern? Is this a perfect square? Is that a perfect square? Can the negative 2x be achieved by doubling the product of x, or the square root of x and 1? Then it must be x minus 1 squared, right? And I'm going to write it this way just so that I recognize that one of them is going to get canceled. Okay? So, the square root of x squared is x. The square root of 1 is either a positive or a negative 1. But doubling the product of a and b will give me a 2. But it will only give me a negative 2 if that 1 is negative. Boom, boom. The answer is x minus 1, but x cannot equal 1. Okay? Start here. That's where your restriction is. X cannot equal 1. Number 6. X plus 6. 36 minus x squared. Anything we can do in the top? No. X and 6 don't share anything. What do we got on the bottom? Difference of squares. 6 minus x, 6 plus x. Does anything in the numerator match anything in the denominator? This and this are the exact same thing. Positive x, positive 6, positive 6. It doesn't matter that they're written in reverse. They match. Okay? So, what do we have left in the numerator? Numerator. 1. Denominator, 6 minus x. Okay? When you cancel out everything that's in the numerator, that doesn't mean this automatically pops up to the top. That means this is a 1. Okay, x plus 6 divided by 6 plus x is 1. So this is a 1 and that is a 1. We simply don't write it down here because 1 times 6 minus x is still 6 minus x. Restriction, 36 minus x squared. So what can make this a 0? What can x be to create a 0? 6 is right. Very good. What else can create a 36? How about negative 6? Negative 6 squared, that still gives you a positive 36. And 36 minus 36, there's your restriction. Okay? 6 squared is 36. Negative 6 squared is 36. In either scenario, you would create a 0. No good. Number 8. I'm going to skip on, just start going a little faster here, because a lot of these are just repetition. Number 8. 2c minus 2d. 2c plus 2d. What are we going to pull out first in the numerator? What do 2c and 2d share? Negative 2? maybe. We could pull out a negative 2. I would just pull out a positive 2. C minus D. And in the bottom, C plus D. Okay? Because if you made this negative, then that would be a negative C and a positive D. It still wouldn't help you here. But it was a great thought, because you will be doing that. The 2's disappear, leaving me with C minus D, C plus D. And C cannot be what? C cannot be D, close. C cannot be the opposite of D. If I plug in a positive 1 here and a negative 1 here, that creates a 0. So if C and D are the same numbers, only different signs, it creates a 0 scenario. You could have even written negative C cannot equal D. Okay, in other words, they can't be the opposite of each other. That's all it is. Same number, opposite, cannot happen. C cannot equal. All right? Number 10. One thing I like to do when they give you something squared is I write it without the little exponent just so that I can see it a little bit more clearly. 2y minus 8 squared over 2y minus 8 cubed. This is the original situation. Okay, this is a lot easier than it looks. This one is 2y minus 8 times 2y minus 8, right? Would you agree that this is the same as that? And I'm not going to pull out any 2. I'm not going to need to. You're going to see why here in a minute. The bottom, 2y minus 8 cubed means it's 3 of them. 2y minus 8, 2y minus 8, 2y minus 8. So far, so good? Where the numerator and denominator match, they cancel. The numerator is a 1. The denominator is 2y minus 8. Okay. Restrictions on the variable. What do you think? Oh my gosh, Connor Rockstar. Y cannot equal 4. He's right. Some of you might have thought, well, 0, obviously. 2 times 0. Yes, that would zero this out, but then when you cube your negative 8, it would end up with a positive result. The only thing that would zero out your denominator is that 4. Okay? So the simplification and the restriction. 12. Okay, this is where what Jared is going to do is going to make this easier. Right, Jared? Okay, right now I have 4 minus x and x squared minus 9. I'm not going to look at this just yet, but I am going to look at this. This is a difference of squares. Would you agree with me? That is x plus 3, x minus 3. Okay, so I've dealt with that. Okay, look at this and this. This 4 is the opposite of that 4. This x is the opposite of that x. So, if I remove a negative 1 from 4 minus x, I get negative 4 plus x. Probably should have given myself a little more space. Negative 4 plus x. Which just so happens to match the x minus 4. It might be reversed, but it matches. When I get to these bigger problems, as I deal with them, I cancel them out just so that in my mind, I don't do it again. All right? So, by factoring out a negative 1, negative 1 times a negative 4 is a positive 4. Negative 1 times a positive x indeed is a negative x. So by pulling this out, I have now created a situation where these can kill each other. Okay? boom, boom. Looks like these go. Okay? The answer is going to be negative 1, x plus 3, or you can just float that negative out there. Okay? And our restrictions. What would make this scenario 0? Well, if you're not sure, x minus 4 times x minus 3, you can solve each piece for 0. What would make that a 0? What would make that a 0? You're going to find that a 4 would make this a 0, thereby making us have a problem. And a 3 would make this one a 0. So those are the two restrictions. X cannot equal 3 or 4. Okay? X cannot equal 3 or 4. And you can write it like this, just you don't have to write it twice. 14. Which of these fractions cannot be simplified? All right, so obviously I'm not going to just go through and factor. When you got through it, did you find that 14 and 16 were not simplifiable? Hopefully you did. 14 and 16 shared a whole lot of nothing. You might look at 14 and say, well, the 4x's match by 4, and the 7y's match by 7. But remember, each binomial is an entity unto itself. You cannot factor out each piece individually, only what both pieces share. So just for additional practice, we're going to do the ones that can be simplified. 4x minus 6y. This is number 13. 4x plus 6y. What can I pull out of the top? 2 is right. 2x minus 3y. There's nothing else there, so you know you pulled out the greatest common factor. Bottom, 2x plus 3y. Hopefully you visually can see. Bye-bye. There's your answer. Okay? Restrictions. They don't even have me list the restrictions on this one. That would be a pain in the rump. I think 6 positive, 4 negative, 6 negative, 4 positive would make a 0. A little trickier. 15. 4x squared plus minus y squared 2x minus y. This is a difference of squares. 2x plus y, 2x minus y. Okay? Square root of 4 is 2. Square root of x squared is x. Since it's a difference, plus minus, square root of y squared is y. The bottom piece cannot be reduced. 2x minus y. You can kill your negatives, leaving you with this as your answer. So restrictions would be x cannot equal negative 1 if y is 2, etc., etc. X cannot be a positive 1 if y is a negative 2. X cannot be a positive 1 if y is a negative 2. They're not going to really ask for restrictions when it's that detailed. That's just too much. I don't think they'll ask that. At least I don't remember them asking that much.